Welcome to NASA Edge.
An inside and outside look at all things NASA.
We're here in the hangar at Vandenberg Space Force Base to talk about the tower rollback for NOAA's Joint Polar Satellite System's second launch, JPSS-2, a very important mission for NOAA in partnership with NASA.
Now, JPSS-2 also marks the 100th mission in LSP's history. And I don't know if you can tell, but I have one of these commemorative 100th mission shirts on. And
Nice.
We'll talk a little bit about that in a little bit. But over the course of the show, we'll talk about history in addition to pulling out a couple of old school commercials from the LSP video archives.
And wait, there's more. If not only that, we're going to talk about a very important technology demonstration mission for NASA, LOFTID. And a good friend of ours, Kristen Damadeo from NASA Langley Research Center, is going to help with those interviews after tower rollback.
So before I head on out to the pad with Mick Waltman from LSP to talk more about rollback, you know what they say, you don't know where you're going until you know where you've been. Let's take a look at LSP's history.
Status check proceed with terminal
And now coming to us through a downlink from the TSL. T-minus 10, 9,
T0 plan for 0205.
and liftoff.
You never forget your first. And my first mission I worked was the demonstration of autonomous rendezvous technology. Basically, it was demonstrating the technology of autonomously docking to a spacecraft in space. At the time, I didn't really understand or know what that technology was being used for, but now that technology is being heavily used today.
My first assignment was Lucy as a backup integration engineer. I felt overwhelmed at first, but I started to realize I had the full support of my management team. I had all of their years of experience that I could count on as sort of standing behind me. We hit our mark. We launched on the first second of our planetary window that we've been targeting for over 3 years.
Sojourner was my very first. Ever since that mission, I've been a part of every other rover that has landed on Mars. Spirit and Opportunity. I was also the launch director for MSL and Curiosity. So those are always something that I could look back and say, wow, I was fortunate enough to be in the right job, to be able to do this and do my little part to make that happen.
After experiencing my very first LSP mission, I think is when reality hit me that I get to be a part of this incredible team that's making history, really, and is helping all of humanity, which is amazing.
Imagine watching every LSP launch, ever.
0 and liftoff.
From the moment of liftoff to spaceship separation, all the way to booster recovery. With this once-in-a-lifetime collection, you can now own every heart-stopping moment of LSP's greatest hits. Introducing NASA Edge's ultimate LSP video collection with missions like Icon, TESS, and even Parker Solar Pro. We see you, son. Own this 2-volume VHS bundle for just $19.98. You'll get 64 hours of blast-off after blast-off for less than the price of an 18-minute long-distance call to Micronesia on off-peak hours. But wait, use your credit card and we'll include this limited edition LSP t-shirt for absolutely free. Include an extra $22 for shipping. The Ultimate Launch Service Program VHS will not be sold in stores. Operators are standing by.
Call 1-555-800-1LSP to order the Ultimate LSP Collection on 2 timeless VHS tapes for $19.98. Use your credit card and get the one-size-fits-all medium LSP t-shirt absolutely free. Launch coverage commentary only available in a Midwestern English dialect. Why wait? Order now.
We are very excited to have with us today Tim Walsh from the JPSS program director, correct?
Correct. Thank you so much, Blair.
It's great to have you on the show.
Great to be here.
And I want to talk first. We're celebrating LSP's 100th mission. How does it feel to be part of their legacy.
100 missions is a tremendous legacy, and they're failure-free. And so JPSS, this is our first mission on an Atlas, and we're thrilled to be the 100th.
It really is kind of a cool thing to be part of, for
It really
sure.
is. It really
Now,
is.
I do want to talk about JPSS broadly first. We're all excited about the launch and the rollback, but let's talk about the system as a whole. What is JPSS?
JPSS, the last S in JPSS, it's Joint Polar Satellite System. So we are, in fact, a series of 5 satellites. There was a predecessor satellite called SNPP, and then JPSS 1, 2, 3, and 4. So we are the third of 5 in the system.
A little bonus satellite there.
It is a bonus. That first one is a precursor, and it worked out remarkably well.
Well, I want to talk about that for a second. So when you started, you didn't maybe necessarily know that it would develop into this full system. You kind of had to prove yourself.
We did. We were using 4 really, truly cutting-edge instruments on SNPP. And then those instruments now are used in JPSS-1, which is now called NOAA 20 on orbit.
Yep.
And then we have JPSS-2, we're so excited to see in orbit.
Okay, so talk a little bit about what JPSS-2 and its predecessors actually provide for us from a data standpoint.
Well, the first thing that's most obvious to anybody who's looking at the data is the visible imagery. So you can see forest fires, flooding, severe storms such as hurricanes. And then we have something called sounders, 2 specific sounders, one that's called a microwave sounder that can basically look through clouds and look at storm structure. It's kind of like looking at a MRI of a storm. And then there's something called a CRIS, or a cross-track infrared sounder. Together, these 2 things give us a very fine perspective of the vertical resolution of temperature and humidity all around the world.
It's very impressive. And one of the things that impresses me all the more is that you guys have worked in partnership with NASA to develop these. So tell me a little bit about that partnership.
Yes, NASA's been around since, of course, 1959, and in 1960, NASA launched the first weather satellite called TIROS-1. And so we are actually a direct descendant of TIROS-1.
Nice.
And so we started, NOAA became an agency in 1970, and we've been working with NASA ever since.
Well, now it's amazing, number one, that you could be part of this long legacy, but here we are, we're on the brink of rolling back for JPSS-2 and then launching. Obviously, once it flies, and separates and goes through all its procedures and everything, it starts to provide this data. Talk about your relationship with the meteorologists that get this data. It's got to feel pretty special.
It is special. When I first started working in this business, I worked on satellites that weren't as obvious to everyday users. And so I love the fact that a lot of people, the first thing they do when they get up in the morning is get some coffee, look at the weather, right?
Fair point.
And so almost everyone that's looking at their phone is utilizing data from our satellites. And so it's really rewarding to see not only how everybody can use this satellite, but how when we talk to the scientific community, they're so excited about the extra data that we're getting from this. And this extra data will go into numerical weather prediction models, which will give us better 3 to 7 day forecasts.
Which, I mean, I don't know about you, but even the most average, everyday person can appreciate more information when it comes to weather prediction. That's for sure.
Weather is a difficult industry to be in because you get a lot of criticism, but I do love to see how over the last 20 years we've improved those weather forecasts as compared to truth measured on the ground. And it's been, and I can see the accuracy getting better year to year.
Awesome. We love that. Well, Tim, thanks for being on the show.
And thanks so much for having me, Blair.
We look forward to great success with JPSS-2.
So do I. Thank you.
Franklin had a chance to sit down with A.J. Coleman to talk more about JPSS-2.
I'm here with A.J. Coleman, who is the JPSS project lead. How you doing, A.J.?
Doing great. How are you?
I'm doing pretty good. So JPSS-2, this is the second in the line of the JPSS satellites. It's launching 5 years after JPSS-1. Are these satellites identical? If not, what's the difference?
So they are very closely related. The instrument suites are nearly the same. The primary differences being, one, it's built on a different bus. So we have a different company actually making the thing that we attach the instruments to. And we have a slightly different instrument profile. We no longer have Ceres, which measured the Earth's radiant energy, and we've added in a limb profiler to our ozone monitoring instrument. So as well as looking down, which we call a nadir view towards the Earth, it can also look back and see that nice little sliver of atmosphere between space and the Earth to measure ozone there as well.
Well, you just mentioned 2 of the instruments. Can you name Was it 4 instruments on JPSS-2?
4 instruments on JPSS-2. The VIIRS, which is a visible infrared radiometer. That's the nice one. We call that the moneymaker. It takes pretty pictures as well as other actual scientific data. There is CRIS, which is a cross-track infrared scanner, which means as we go over the Earth, it's measuring this way. So it kind of sweeps back and forth as we travel. There is ATMS, which is a microwave sounder, which also works the same way. And then we have OMPS, which I mentioned before, which is a ozone monitoring instrument.
How do these instruments enhance the collection of data for this continuous data record?
The data that NOAA collects has been evolving and improving since 1960 when they launched the first TIRO satellite. The instruments that we have now actually started with NPP, which is the satellite that came before J1 that's very closely related to it. Because we have built several versions of these instruments, and by versions, I mean they're very much the same, slight improvements, updated pieces of hardware in them from time to time, but very much the same instruments. You will have a continuous data record from NPP launch through J1. J1 and NPP are still working. We're launching J2. J3 comes in 2027. J4 comes in 2032, and we expect these satellites to last a very long time. So even though the mission life expectancy is 7 years, it would not be uncommon to get 10, 15, 20 years out of these satellites, where our scientists could compare apples for apples science data over a 30 or 40 year period.
JPSS-2 is not your first rodeo when it comes to the JPSS satellites.
That is correct.
What is your work going to be with JPSS-3 and beyond?
As a me, I will probably maintain a role of engineering oversight. I don't do much wrench turning anymore. I try to stay off of the keyboards. I don't want to get too loose and code something they don't like. But really, what I do on a day-to-day basis is really supporting the engineers and our NASA NOAA customers, making sure they have the right training, guiding them through some tougher technical issues. I have about 14 years of satellite operations experience. I've done 2 launches now. This will be the 3rd one I've participated in. So really just helping groom a lot of the younger employees and making sure we're meeting customer requirements and really helping out NASA and NOAA and keeping that relationship strong.
Joining us now is Jordan Girth of NOAA's National Weather Service. Jordan, thanks for being on the show.
Glad to be here.
We've heard a lot about the instruments for JPSS-2 and all the work that it's doing. As a meteorologist, you just have to be excited about all the data that you guys get.
Absolutely. The imagery and the data that we get from the Joint Polar Satellite System is absolutely incredible. Not only is it global, but the resolution of the imagery, the spatial resolution over the contiguous United States helps us to determine things like burn scars, flood extent, and also the severity of weather systems.
Yeah, and that's really important because, those are real world issues and things we have to deal with. So, and not just being pretty pictures, but real actionable data. How has this helped you and meteorologists help people prepare for bad weather?
The JPSS system, and we already have one of the satellites in the series up there now, JPSS-1, launched a few years ago. Those satellites are the most significant input that we have to these sophisticated numerical weather prediction models. Those numerical weather prediction models are really what help meteorologists build forecasts that are accurate at the 3 to 7 and increasingly to the 10-day range. So with that global weather prediction, with that global weather observation, we're able to build a nice 3 to 7 day weather prediction.
Now, we've just had a big significant storm in Hurricane Ian. Was JPSS involved in helping make determinations about what we should do as the hurricane approached?
Our National Hurricane Center meteorologists use a lot of satellite data because there's very few other types of observations over the ocean. We have a few buoys and we rely on ship reports from mariners. Those are important to us. But to get a sense of the storm expanse and the storm structure, that's where these satellites come into play. In JPSS in particular, there's a couple things that we saw in the JPSS-1 data to really help us understand that storm, one of which from the Advanced Technology Microwave Sounder gave us a really clear indication of the eye wall, a very strong signature that indicated the intensity of that storm.
Now, how does that compare to previous storms where you didn't have that data?
Well, if you dial back the clock far enough, we didn't have any satellite data, and of course that was really, really difficult to deal with, right?
Yeah.
There was a lot of chaos in coastal areas with that uncertainty of not knowing. Maybe you heard from a faraway ship that there was something out there, but where was it going? Was it headed toward the U.S. landfall or not? Mm-hmm. So as we've gotten progressively better satellite observations, we've been able to resolve these storms more precisely. So we get higher resolution, and the JPSS series is multiple satellites, so we can make sure that we're always going to see that storm system several times per day as it makes its way toward land.
Well, I don't know about you, but I'm very thankful that you guys are doing the work that you're doing, preparing people for storms and analyzing and using that data well. Jordan, thanks for being on the show.
Glad to be here. Go JPSS-2.
Awesome. Now we're going to take another look at this tremendous 100th mission for LSP.
Liftoff of the Falcon 9 and DART on NASA's first planetary defense test to intentionally crash into an asteroid.
In my time during LSP, the most significant demonstration of technology that I've seen has to be the DART mission, the Double Asteroid Redirect Test mission.
Essentially, we launched a spacecraft. It traveled over 6 million miles to an asteroid, and it crashed into it.
This was mankind's first attempt to prove that we're smarter than the dinosaurs. The dinosaurs had a horrible space program. They had no way to protect themselves against an asteroid coming in to wipe them out.
First of all, that's the type of stuff you see in a movie. So just starting from that, I think that's really unique and really cool that it's not actually a movie. We're doing this in real life. Like, we do this for work.
My favorite mission, even though that's a difficult question to answer, has to be the MER missions, the Mars Exploration Rovers, that's Spirit and Opportunity. We launched those in 2003. That happened to be a mission that I worked from beginning to end as a mission manager. I got to meet really exciting people. I got to meet the scientists involved. I still have friends that I made back then from JPL and headquarters. And overall, I think it's the one that always stays in the back of my mind as my favorite mission.
So I think I would pick the New Star mission. It was launched out of Kwajalein. I had never been in that part of the world before. And by the time you get there and you're set up with the whole team, you're very consolidated and you're very slimmed down to just the absolute necessary functions to support the mission. Didn't have the connection back to the mainland that you would normally have, and so you all had to get together and work all the problems together. You had no cars, you had to ride bicycles. So there were all kinds of not just the challenges with the mission, but challenges with the living environment and what you had to do. So that one is pretty memorable to me.
We're live here at Slick 3 at the Vandenberg Space Force Base, and I'm joined today by Mick Waltman from LSP, friend of the show. How you doing, Mick?
I'm doing great, Franklin. Glad to be out here for this mission. Looking forward to this.
Absolutely, Mick. Now, behind us is the MST, the Mobile Service Tower, and behind it is the Atlas V and the 401 configuration. Can you give us an update as to how things are going on this evening?
Yeah, absolutely. The team has been on console for a couple hours now. They got the vehicle powered up, testing things out, getting ready, checking out ground systems. They have run into a small issue on the ground system with a leak that they've noticed, so they're doing some troubleshooting right now on those ground systems, making sure everything's ready to go for the J2 launch later this morning. And that's pretty normal for the team. They've got some built-in holds in the countdown, so everything's still moving forward on schedule, just working through those ground issues before they get ready to move the MST.
Okay, so for those of our viewers who, maybe haven't been on, watched any of our shows, here we have a rollback. The tower is going to roll back to expose the Atlas V. Now, back in the Cape on the East Coast, we have a rollout where the launch vehicle leaves the vertical
integration facility,
the VIF.
Yep.
Yes, And that's the difference in these two procedures.
Yeah, here at Space Launch Complex 3, it's got a long history here, starting back in December of 99 when they launched AC-141 from here, which was the first modification after the early ICBM missiles that were launched here, Atlas missiles. So EOS Terra launched here, that was the first one. LSP was actually part of that mission. And then today we've got the J2 Atlas V launching here. So this pad was always built with a mobile service tower that rolls back about 300 feet and it moves the whole tower. As you said, the clean pad concept that ULA has in Florida, they do all their integration and work in a vertical integration facility, and then they roll the vehicle to the pad, and that allows them to get more work done, clean pad as far as keeping the pad just operational from that aspect.
Tell us a little bit about the Atlas V and the 401 and some history that's taken place.
So yeah, I mentioned AC-141 in December of 99. That was the first mission for us LSP off of Slick 3 here. J2 will be our last Atlas V from Vandenberg Space Force Base. It is the 41st Atlas V for United Launch Alliance in the 401 configuration, which has been a workhorse for United Launch Alliance and NASA LSP. This is NASA's 100th mission. So LSP is very proud to be bookending the history here at Space Launch Complex 3 with our commercial partner, United Launch Alliance. They've been a huge help to us over the years, getting our scientific missions on orbit, and we're just so happy to have J2 and the LOFTID mission launching here today from this historic pad.
Now, this Atlas V that's taken off, it doesn't have any solids on it.
Yeah, that's the 401 configuration. 0 solids, because the performance we have here to get into polar orbit
position J2 in orbit near J1. It's almost like putting it in a parking space.
Yeah, so right now we have J1 that's up there now, and then another satellite NPP. And as we get ready to launch J2 tonight, we're going to put it in a specific spot about 180 degrees out from J1 in this sun-synchronous polar orbit that they're in. Going over the poles, north and south, every 14 days, taking pictures of the Earth as it spins. So it is very, it's needed to be able to get it into that parking spot, like you said, and that's why we're using the 401. Due to reliability and the accuracy that they've had over the years, we're going to launch that rocket tonight and put J2 exactly where it needs to be.
And the follow-on be positioned in the same way.
NOAA's working on, eventually when we get, they will put those in a similar orbit, and NOAA then can look at Earth from different spots in the same polar orbit using all the satellites that they have up there, allowing them to get better data, better capabilities to look at weather.
Hey, Mick, what great. You know what? Rollout is forthcoming.
Forthcoming, yeah.
Roll back.
Roll back, yeah, not roll out. Roll back. We're going to move the MST.
Absolutely. So you all just make sure you stay tuned into NASA Edge and NASA TV, who has the broadcast coming up later on this evening into the morning. But right now, we are going to go to a word from our sponsor, LSP.
Are orbital insertion challenges keeping you up at night? Has your spacecraft experienced rapid mass or weight gain? Have changing mission requirements caused anxiety about scheduling and cost? There is a simple solution. Try LSP. LSP is NASA's all-natural, 100% organic answer to those struggling with the chronic symptoms of mission planning. Once you start using LSP, the discomfort of mission management should subside. It is not uncommon to see immediate results, such as mission mass stabilization, appropriate load analysis, launch vehicle identification, and a reduction in manifest phobia. LSP is safe for all scientists and engineers. However, please consult with your physician before using LSP, as mission success can be followed by extreme professional euphoria and promotion. Start using LSP success. Proper launch vehicle selection, integration, load, and successful launch and deployment of your spacecraft.
Personally, I've used LSP for years and I've suffered no side effects, only benefits. But please check with your doctor. And joining us now is Joe Del Corso of LOFTID. Joe, thanks so much for being on the show.
Thank you for having me.
Well, I tell you, we're really excited. I mean, JPSS-2 is an important mission, but this very special mission of LOFTID, this technology demonstration, is also extremely important for NASA. Tell us about your role with LOFTID and what it does.
So, like you said, I've been with LOFTID for a very long time. I am the project manager for it. LOFTID is the low Earth orbit flight test of an inflatable decelerator. What this is, it's a technology demonstration of a specific technology called HIAD, the Hypersonic Inflatable Aerodynamic Decelerator. So this is a technology that's been in development for almost 20 years at this point.
Wow. Now, you've tested HIADs before, but this is the first full-scale test of LOFTID?
That's correct. So what we've done in the past is we've tested 3-meter articles, sending them straight up into space, bringing them straight back down. The difference between that and what we're doing now is we're going to send our article into orbit. So there's much higher energy, and it's a much more it's a test that really actually shows that this technology is matured to the point where it can be used for mission infusion for NASA and for commercial applications.
I want to talk about those commercial applications, but first, just the materials. Some of the things I've seen, this shell on the outside. I mean, how did you guys come up with that?
A lot of years of trial and error and working with subject matter experts who are just phenomenal in their field. So the outer fabric itself, we use silicon carbide. We found out that we could use SICK, Nextel, and a lot of other fabrics, along with a whole series of different insulators. We got the original concept from the aft skirt of the Delta IV, which would take plume impingement.
Interesting. So you actually built on previous work and turned it into this cool tech demo.
Absolutely.
Now, I understand you'll come from orbit and you'll actually go through the deceleration process. How will the rest of the mission play out? Because I understand everything's going to happen fairly quickly after launch.
That's correct. So the mission itself, we launch out of Vandenberg on an Atlas V. Once we get up to orbit, the primary mission, JPSS-2, will be put on orbit, and then next stage will be the Centaur second stage, doing a deorbit burn to set up LOFTID for reentry. We will basically set up for reentry as we come over the pole, and then enter right and decelerate and splash down right off the coast of Hawaii, about 500 miles.
And that's happening pretty soon after launch.
That's correct. It'll be about 2 hours after launch.
Wow.
Yeah.
So you got to be excited. This is going to be incredible.
It's been a long road getting from initial concept to this point, and years and years of development and trial and error with materials and structure systems. And we've had an absolutely phenomenal, both commercial group of folks working with us and a dedicated team at NASA.
Now, it's interesting you mentioned commercial interest. Talk a little bit about that, because, if this works, seems like a lot of people might be interested.
We've had a lot of folks approaching us, especially recently. ULA approached us a couple of years ago with the original concept, and they're our partners on this particular mission. Their plan is to utilize the HIAD technology for a system called Smart Reuse. They want to be able to bring back their thruster cluster, and that'll bring down the cost of access to space. In addition to that, we've had interest from Outpost and a couple of other commercial entities who'd like to be able to re-enter heavy payloads to Earth.
I tell you, this is all very exciting, Joe. We're very excited. We want to see is it a splashdown? I mean, do you call it the splashdown?
It's a splash, yes.
When that happens and you guys are successful, where are you going to be waiting for the data?
I'll be here at Vandenberg in the control room, pretty much going crazy once I see the data coming in.
We love that. We'll look for you going crazy. Thanks so much for being on the show.
Thank you for having me.
All right, we're going to look again at the NASA LSP 100th mission celebration, and then we're going to hear from Kristen Damadeo from NASA Langley Research Center as she learns more about LOFTID from Angie Emmett, Senior Project Engineer.
3, enable 2. Status check to proceed with terminal count. Which is ready position.
Here we go from NASA Launch Manager Tim Dunn.
Go, and you are reached out. JPSS-2. Go out on 02 T0 land for 0205. And liftoff.
It's been said many times, I'm not the first, won't be the last, but we really consider LSP to be a family. And by being kind of small and flexible and agile, we really have grown incredibly tight over the now 24 years that we've been a program.
Working with LSP is working with family. It's not even like family, it is family.
There's a lot of stress in the jobs that we have. We are trying to make sure that a spacecraft gets launched successfully where it needs to go for people who have worked on it, their whole lifetimes. And so that's a lot of pressure on the people in the organization. And so when you accomplish that launch, you've done it together as a team. And so we all come together like a family to solve the problems and to get the mission done. And we're all working to achieve the same goal.
The one thing I love about it is we make each other better. It's not just about the launch day, but the little things that we do all day, every day that make the workplace enjoyable.
I actually got hired on during the pandemic, and even though I was not meeting people like I normally would, I got to experience that family. And so I think it's something that really it's woven throughout the fabric of the program. And so there's a culture within LSP where people don't have to look behind their back, afraid that someone's going to step on their back to get to where they want to go, but instead there are people who have your back and are pushing you forward so that you can be successful and so the program can be successful. And so that's where that family atmosphere comes from. It's talked about, but it's not just a saying, it's a lifestyle. And so it's really cool to be a part of that.
Come on down to Madman Allen's Used Rocket Emporium for all your rocket needs. I'm Madman Allen, and I'm mad for used rocket engines. We got vintage rockets. We've got two-stagers. We've got boosters. Check out our inviting selection of Pegasuses. Buy two and we'll throw in the plane absolutely free. We've got Atlas 5s, we've got Vulcans, we've got Falcons. You like them heavy, we got them too. Look at this beaut. I've got so many rockets, we're giving them away. Forget the Alphas, we've got Deltas. Need a lightly used engine? Madman's gonna set you straight. We've got Minotaurs, we've got Falcons. Did I say Falcons? Bring that old bucket of bolts down to Madman Allen's Used Rocket Emporium and we'll put you in the launch vehicle of your dreams. Take exit 5 off I-95 and drive that sucker all the way down to the coast, then turn around, head back about 2 miles to the Gulf Coast rest stop. We'll be by the picnic tables. Drive in with the car, blast off to a star. Like my mama used to say, science is fun if you own a rocket.
Hi, Angie. Thank you so much for joining us today. We're getting so excited for the LOFTID launch. Can you tell us a little bit about, as a mechanical engineer, what is your role with LOFTID?
Oh, mechanical engineer is a great role on LOFTID because we get to be a part of the vehicle from the design phase. We get to be there when they machine the parts, when they fabricate the parts. We get to be there for the assembly, for the integration, and for the testing, all the way cradle to grave from design to launch.
So this is a follow-on test to several other iterations of an inflatable decelerator that have flown before. What is different about this test, this spacecraft? What kind of challenges did you face in building this?
Yes, it is different. So there's a couple of areas that it is different. So this time we are actually going up and we're going to orbit the Earth and come back down. So that brings a challenge of recovering. We're going to splash down off the coast of Hawaii in the ocean. So we have to be able to get to the splashdown site. We have to recover the vehicle. At least we'd like to recover the vehicle. Get it out of the water. It's going to be waterlogged. It's going to be holding some water. Get a boat with a crane. Get it off of there. Also, another big challenge is just the size. It's a bigger vehicle. It's the 6-meter diameter aeroshell. When it's inflated, it's very rigid. And when it's deflated, it's soft goods, so it's floppy. The heat shield is a silicon carbide, so you have to wear protection when you touch it. Yet it's really delicate, so you have the way you handle it. It's 400 pounds of just floppy material that you need to handle. So that's another challenge as well.
Sounds like it was a lot of work to figure out how to pack it into the canister that it's going to be launched in.
Yes, they had lots of practice and did lots of testing to ensure that they could pack it within its volume. We also brought that equipment to pack it here to Langley because we did have a test where we deployed it in a vacuum. So once it was deployed, we needed to pack it back again. So we had all of the machinery to do that here.
So LOFTID is going to be packed, but it's also going to be packed into the ULA rocket with another payload. What did you have to do to overcome any challenges with regards to being a rideshare?
So we did work very closely with our partners. We needed to ensure that we fit within the required volume and that we had the mechanism to attach and separate from that rocket. Now, being with another payload, we had to adhere to their schedule because if we're not ready when they launch, then we lose our ride. So we want to ensure that we definitely maintain schedule, that we're cognizant of that, and we're also cognizant of the materials that we use because we don't want to contaminate their payload.
So Angie, you mentioned that LOFTID is going to splash down in the Pacific Ocean. Did you have to do anything specific or anything different with the spacecraft so that you'd be able to find it?
Oh, yes. Yes. We have several items on this vehicle to make sure that we can find it because it is going to be in the middle of the ocean. And of course, we want to recover it.
It'll be dark, right?
Depending on how long it takes for the boat to reach the instrument, it could be daytime, it could be nighttime. If it's nighttime, so we have a couple of different features. If it's nighttime, we have some flashing lights, some kind of aircraft lights. We also have these mirrors that will reflect light back at you from any angle. So any angle that you shine a light on it, it would reflect right back to you. We also have some beacons that will transmit its GPS location too. So we have a number of different ways to be able to find it.
And I heard that there's a new component on this one, like a redundant data system.
Yes, so we're going to have two very similar data modules, and one is going to stay with the vehicle that will be able to recover with the vehicle, but the other one will actually be ejected before splashdown, and it will be able to float also, and it will also independently be sending its GPS coordinates. So we have the ability to find that ejectable data recorder, and then also have the internal data recorder in the vehicle.
What are you excited to see? To you, what will make this mission a success?
Well, of course, all data that we get is great data. We love data. If it comes from the real-time beacon that's going to be transmitting data through the experiment, if it's capturing data from the ejectable data recorder. But what I'm really excited to see is when we recover the vehicle, actually being able to see the physical aeroshell and seeing how the vehicle looks after re-entry. I think that's going to be really exciting.
Very cool. Well, that's really great and very exciting. Thank you so much.
Thank you.
Joining us now is Stephen Tobin, who's the lead thermal engineer for LOFTID. Stephen, LOFTID deploys a flexible thermal protection system. I imagine that has to be challenging to develop a protection system that's flexible. Can you tell us about the challenges involved in this project?
Yeah, so the flexible thermal protection system is made of these layers of flexible blankets, and we have to build them so that they're thick enough to protect the underlying inflatable structure from all of the aerodynamic forces and aerodynamic heating during hypersonic reentry. But they have to be thin enough so that they can be flexible for folding and packing, and strong enough so that they can handle all of the loads associated with deployment and the aerodynamic forces of reentry as well.
You said blankets. Can blankets really be solid enough to actually help the payload as it enters our atmosphere or another atmosphere?
Yeah. Well, the thing about an inflatable decelerator is they can deploy to very large sizes, much larger than traditional heat shields, aeroshells. And so with that, it can actually decelerate higher in the atmosphere where the air is less dense. So it actually doesn't take as much heating as your traditional rigid capsules would, where they decelerate much lower. So the requirement for max heating and total heat load is actually less than what your traditional heat shields are.
And I guess that flexibility gives you a lot of advantages with regard to mass and size, which is very important depending on the types of things you're taking to another surface.
Yeah, we're able to carry a lot more mass with a larger heat shield decelerating higher in the atmosphere.
Talk about the process of actually taking this heat shield and packing it for deployment, because you want to maintain the integrity. What are the things that you're looking for when you condense this down to make sure that it's still safe when it deploys in the atmosphere?
So yeah, it has to be able to condense down to a very compact state without abrasion of mainly the outer surface, outer fabric. That's going to be protecting the heat shield from aerodynamic forces and direct heating, but also the inner insulators, particularly around the shoulder area, which have a high bend radius, are going to be very vulnerable to abrasion during that packing process. So on our engineering design unit, it went through 3 packs in deployment, and then we completely, deconstructed it to make sure that we had no substantial damage to the outer fabric or the insulators on the inside.
Now I'm wondering, when you have it deployed and it's actually being tested, how do you measure its effectiveness? Thinking about the flexibility, normally we put some sensors in there, but with this flexible system, how are you going to get this kind of important EDL data to determine whether LOFTID is a success?
So we actually route thermocouple wires at various body point locations from the nose all the way outboard to the shoulder of the heat shield, so that we can get a total in-depth profile of the thermal response during flight.
When LOFTID completes this tech demo and splashes down, your work continues because you'll want to look at all that data.
Yes, yeah, it's called post-flight reconstruction, and we're going to be correlating our thermal models to the flight data to both validate them and improve them, so that we can have a solid foundation for design of these inflatables for future missions. Yeah, so that's really how LOFTID is going to help us.
Joining us now is Caleb Weiss of the United Launch Alliance. Caleb, thanks so much for being on the show.
Thank you for having me.
Well, we've listened to a lot of people talk about the importance of the data for LOFTID for NASA, but I understand ULA has a very keen interest on this data as well. Can you tell us a little bit about ULA's interest in LOFTID?
Of course. First of all, it's a joint experiment between ULA and NASA, so the mission itself is just exciting for us, and so happy to be partnering on it. But the data itself is really going to help inform us on our engine reuse program. We are looking at using the HIAD technology to provide a decelerator to our Vulcan engines, bring them back, and be able to reuse them multiple times.
And as far as I know, there's nothing else like this being used anywhere currently.
There really isn't. It's very new technology. There have been test flights of HIADs before, but LOFTID is really going to be the first time where we're flying a big 6-meter HIAD, capable of bringing significant mass down behind it. We're looking at an even larger HIAD for our reuse program. So we are looking at separating the aft end of our booster, bringing the engines back. The great thing about a HIAD is it's inflatable, so when it lands in the ocean, it doubles as a raft, and so we can get the most valuable parts of the booster back just by using a decelerator like the one flying on LOFTID.
Now, I know I might be speaking a little bit prematurely at this point, but I know you guys are working on a new rocket, the Vulcan.
Yep.
Can you tell us a little bit about the Vulcan and whether it has the potential for reuse?
Absolutely, yeah. Vulcan has always been designed from the beginning for having reuse provisions, and it's really exciting time to be in launch vehicle development right now, because we are really starting to move forward on even more reuse designs, starting with the most valuable parts first. So that's why we're first looking at recovering the engines. And when you go to build reusability into your vehicle, there's lots of ways you can do it. You can add additional fuel and do engine burns to bring things back. The key is, with any reuse program, you've just put all this energy into the vehicle to try to get it to space, and now you have to pull all that back out. The thing we love about the HIAD is that it uses atmospheric drag to bleed off that energy. So we don't have to carry extra fuel. We're not taking any performance away from the payload in using fuel for coming back. We're simply deploying a large drag device that then allows us to slow down as we come back through the atmosphere. We'll deploy a parachute for the last section of the descent, and then we'll land in the ocean and pick it up with a boat.
It's very exciting to be actually part of this tech demo, especially considering how it may be a feature in a ULA rocket in the future. Pretty awesome. Now, I'm also wondering, ULA obviously important for the engineering and science of a launch vehicle, but this mission is dedicated to a ULA employee, Bernard Kutter. Could you tell us a little bit about him?
Yeah, I got to work a lot with Bernard. He was such a visionary, and I mean, he could look 10, 20 years down the road and see technology like this that was just going to change space. Something like a HIAD allows you to bring something back from space, which we don't do very much right now. Unless it's a crew or cargo capsule, most of what's up there stays up there. And, he had that vision to look out at this kind of technology and know that this was going to have value across the industry. And I think what was so special about him, though, was not just that he could he just dreamed things up, but also implement them. I mean, LOFTID is here flying today. It's a real thing, and that takes a lot of effort, day in and day out to, form the partnerships, line up the funding, develop the materials, everything that goes into actually bringing a new technology to market. Bernard could do that, and that's why we're seeing LOFTID today. And he would be absolutely elated to be seeing this fly. He worked so hard on it, and we miss him every day, and especially on days like this where something that he's played such a big part in is ready to go to space.
I'll tell you, we're really impressed with this and excited about this and hope it has great success. Thanks for being on the show.
Yeah, thank you.
We're going to now look at another one of the 100th mission legacy moments for LSP. It never gets old.
3, 2, status check to proceed with terminal 10.
From NASA launch bay.
LD is go and rocket launch status.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
Rocket launch is anything but boring. I mean, it's exciting. No matter how many times I've seen it, it never gets old.
When you talk about launch, it never gets old, right?
Each mission that we work is different. Each day that we are supporting these missions is different, so it never gets old.
And liftoff.
There's something about witnessing just the sheer impressiveness, just the power of what it takes to pull a spacecraft out of the gravity well of Earth that we live in and to send it out of Earth's orbit on its way to the moon, Mars, the sun, asteroids, even out of our solar system. I'll never tire of watching that.
It never gets old. It really never gets old.
Seeing rocket launches never gets old.
It never gets old. You always are thinking about what's the next one? What's the next one I can do?
This was my childhood dream. This is what I dreamed of doing. And you get to be a part of something that's so much bigger than yourself. And to me, that was the best thing that my childhood self could ever ask for.
Well, we're back at Slick 3 here at the Vandenberg Space Force Base, and I'm still joined here this evening by Mick Waltman from LSP. Mick, launching these rockets is not like driving a car off the car lot. A lot of things have to go right. Can you tell us a little bit about the delay that we're having right now?
Yeah, there's a lot of things that have to go right, and the team is working through them. They are following their process and procedure. They're working through the launch countdown. And as we talked earlier, Franklin, they've got to complete certain steps before the MST can move, because once the MST moves, we don't have access to the rocket anymore. So the team came in earlier, moved some decks, prepped the MST, the mobile service tower, and then they were performing ground checks and ran into some issues that they're checking out right now before they do that. So again, we've got plenty of time in the count tonight. We've got holds built in for the team to troubleshoot issues like this. This is why the procedure is written the way it is, and the team is following that. Launch conductor Doug Lebo from United Launch Alliance is keeping his team on track and working through those things and talking through the stuff they've got, and I'm confident they'll get these fixed and we'll still get off on a launch on 1:25 a.m. this morning.
Sounds good. Now, for those who don't know, you talked about the launch window and the amount of time that the crews and the teams here have to get the launch vehicle prepared to launch. Can you tell us a little bit more about those windows and how that timing works to, launch these rockets?
Yeah, so one of the things we do at Launch Services Program is we work with our commercial partner, in this case United Launch Alliance, to identify the requirements of the spacecraft, in this case JPSS-2. Once it's decided where the JPSS-2 needs to go, we do a lot of science and math, work through that analysis, and figure out what launch window we can have when we have to launch. So for example, tonight, 1:25 a.m., puts us in a unique position to get JPSS-2 into the polar orbit in that spot that we were talking about earlier, that parking space, right? To be able to do that. So the window tonight for J2 is a long one. However, due to other things that are in space, including J1 and NPP that we talked about, we need to block out some of that time so that we don't interfere with those spacecraft once we launch. So our window is about 36 minutes this evening. As we work through that, there'll be a COLA assessment done during the count to verify if there's any other what we call cutouts or avoidances we have to make. But right now, the team is doing good and working through that. So they'll do that. Now, here, as I talk the launch procedure, moving that back, the team figures out where they need to be. We usually start tanking about 2 hours prior to launch, and then they'll back the procedure up from there to do MST roll and the checkouts that they're doing right now. And again, built into that procedure, they have some built-in holds that they can work through to check these things out, just like they are this evening with this small problem that they're working on the pad.
Well, this is what has to happen.
Yeah.
This is part of the
launching rockets is not easy.
It is not easy, and this won't be the last time that we're sitting here waiting for a rollout or a rollback. But one thing we are talking about today is LSP's 100th mission.
Yeah.
Which is a J2. Do you personally have a favorite mission from LSP?
I do, actually, and it is a United Launch Alliance mission also. It was an Atlas 551. It was our first one with ULA back in 2006. It was Pluto New Horizons. I am a true believer that Pluto is still a planet, and so don't ever forget Pluto.
Right.
But we sent a spacecraft out to Pluto and on into the Kuiper Belt to do some very unique studies. Dr. Alan Stern was the principal investigator for that mission. They worked a long time to get it there. We launched that in 2006, and then 9 years later, Pluto New Horizons went by Pluto and took some great photos and everything. Unfortunately, during that time, someone decided that they wanted to downgrade Pluto after we had launched the satellite. But I still believe Pluto is a planet, Franklin, and that is one of my favorite missions too. I was actually the vehicle systems engineer who sat console for that mission as the assistant chief engineer, and it was a lot of fun to work with the United Launch Alliance on that and get the Atlas V off for LSP.
Now, LSP is working with ULA on this mission, but you also said that after this Atlas V is launched, they are going to make some modifications to this pad for the next generation of launch vehicle, which is Vulcan.
Yes, United Launch Alliance has working on their Vulcan Centaur rocket, which is their next gen, both on the East Coast and the West Coast. As we said, this is the last Atlas V from Vandenberg Space Force Base here at Space Launch Complex 3, and it's exciting for that. But as soon as this mission gets off, United Launch Alliance will start modifications here to get ready for the Vulcan rocket out here on the West Coast. While they continue launching Atlases on the East Coast, they will be doing parallel modifications on the East Coast also for that Vulcan Centaur rocket. And we in LSP are excited to be working with them, looking to the future of what Vulcan Centaur will bring us and the missions that they'll be able to support with that next generation rocket.
I'm getting excited about it, because I've seen the models, I've heard the ULA personnel talk about Vulcan. So when you roll out something new, it's shiny and it's special. So we're definitely looking forward to covering the Vulcan launches in the future.
Yeah, I think the United Launch Alliance is looking forward to it. Also, Mr. Bruno is very excited about Vulcan Centaur. They have their first vehicle indicator. Finishing up manufacturing and production there, and then they'll be shipping that out for some testing on the East Coast. So we're excited to hopefully see some progress next year with Vulcan Centaur and continuing our partnership from NASA and ULA.
2023.
2023. That's I'm crossing my fingers there.
Crossing our fingers. Well, good deal. Now, we've seen, workers out here at the base of the launch pad walking around. Can you tell us what's going on?
Yeah, so as I said, they're doing some troubleshooting with some things they've got going on, but the team is also in parallel. You see a bunch of folks at the base. They are doing inspections and walking around, getting the MST motors ready, checking things out once they get the go for tower roll, that they'll be able to initiate that procedure and pick it up as quickly as possible to be able to move the MST about 300 feet back and then lock it in place and get ready for launch tonight. So the team, as I said, following their procedures and processes, but they methodically check through those things. But there's a lot of stuff going on in parallel also. It's not a serial event.
Right.
They do a lot of things in parallel, and then they have a checkpoint gate at T-2 for tanking. And like I said, launch conductor Doug Lebo and launch director Paul Aragon will make sure the team is following that before they move into the next steps there.
Now this rollback, it's not swift. It takes a little bit of time.
It takes a little time, but they make it look swift. They have a lot of practice with it, and as I said, that procedure, they're very familiar with it. But yeah, it's only 300 feet, but it does take them a little while to get that big tower move back and expose the Atlas V rocket as it's sitting there on its fixed launch platform and the umbilical tower next to it. But they'll get it done, and I'm confident they'll be ready for launch tonight.
Now, real quick, can you say a little bit more about the fairing in its size because of the LOFTID mission that's attached to it?
Yeah, absolutely. That's a great point. We talk about the last Atlas V from Vandenberg, but this is actually also the last 4-meter fairing for United Launch Alliance. Mm-hmm. This was built down in Harlingen, Texas, and hand-painted. The logos are hand-painted on there, but it is the 4-meter, what ULA refers to as the EPF, the extended payload fairing, and they had to extend the payload fairing a little bit. It's a common configuration they have due to the stack of J2 and LOFTID down below. So LOFTID's mounted to the top of the Centaur. There's some adapter rings that surround LOFTID to build up the stack, and then J2 sits on top. So by doing that and having LOFTID underneath, they had to have that extended fairing. So again, exciting mission, last from Vandenberg, last 4-meter fairing, 41st 401 configuration. Excited that ULA is going to finish this off here at Slick 3.
Oh, well, man, this is an exciting time for LSP, an exciting time for ULA, and we look forward to a successful launch here, hopefully in the morning. For Mick Waltman, I'm Franklin Fitzgerald. We'll send it back to the studio with Madman Allen.
Well, first, I just want to thank both Mick and Franklin for being out in the elements late at night in California. The weather is cool and crisp. I'm in the warm studio, but I tell you, the rollback, it normally doesn't take that long, but because of this hold, you guys had to endure a lot, so we're very thankful for that. We're also thankful for the cooperation of our good friends at NOAA and ULA for making this possible, and NASA as well. But that really concludes our coverage for Tower Roll for JPSS-2 and LOFTID. And because the Tower Roll actually didn't take place, for updates, you need to stay tuned to nasa.gov for further updates on the launch and schedule. as you heard Mick say, even though tower roll did not happen during our show at the time it was expected, there are holds, there are conditions in which the tower roll will take place and launch will happen on schedule. So please stay up to date at the website and on social media just to see where we are in the launch and to make sure that if any changes take place, that you'll be able to catch them. Of course, if things are on schedule, you can actually tune in for the launch broadcast, which begins at 3:45 Eastern Standard Time and 12:45 Pacific Standard Time, and catch up on all the latest updates on the launch and hopefully witness a successful launch of JPSS-2 and LOFTID, and help LSP celebrate that all-important 100th mission. You're watching NASA Edge, an inside and outside look at all things NASA.
Oh, it's a privilege. Please call me Tom.
Tom, Victor.
I call you Victor.
And the privilege is mine. It's so amazing to meet you, even virtually.
It's great to meet you. Congratulations on your extraordinary career thus far. It's really what you've accomplished. I have great admiration for.
Well, thank you. And, you know, the movie Top Gun obviously had a huge impact on me. And as much as I want to throw Top Gun quotes at you, I won't. I'm sure you get a lot of that. So thank you, because you had a part in that.
Boy, it's an honor for me. And I can't wait for you to see the next one, Top Gun Maverick. I can't wait.
Oh, I can't wait either.
It's an honor.
I'm ready.
Oh, man. I'm ready to show it to you. I can't wait, man.
Awesome.
So listen, I have a
I'm
few
excited.
questions for you, if you don't mind.
Yes, sir. Let's do it, Tom.
Because obviously you've flown, I guess, 40 aircraft over as a test pilot, many different aircrafts. The F-18 is a naval aviator test pilot. Now, flying the Dragon, SpaceX Dragon, how does that compare to that? And what do you think for yourself, what was the most exhilarating aspect?
Awesome. You know, the Dragon is a touchscreen. The displays are also where the controls are. And so that's quite different than flying an aircraft with a stick and a throttle. And so when I first saw it, I will be honest with you, I was like, I don't know, guys, I need my inceptors. I need something to move around. But as I learned more about what the vehicle does and what its purpose was, the touchscreen